Welcome to today's lesson, solving a system of linear equations in two variables by elimination. When both the linear equations are in standard form, and the x's, the y's, and the constants all line up in their respective places, what we can do is we can do a process of elimination. We want to add the columns. So in this case, we're going to add the columns because we notice that the x's are going to drop out. This only works if you notice when you add the columns, if the x's drop out or the y's drop out. So by adding the columns on the left-hand side, we get 3y equals negative 3. Then we just solve for y. By 3, y equals negative 1. To solve for x, we continue with this unit by substituting. So we're going to take the y equals negative 1, and we're going to replace it in either equation. I'm going to come up there and just plugging in the first equation. So we're going to have 3x plus 6. I'm taking out the negative 1 and replacing it for the y. So negative 1 is going to take the place. So this variable here is y. It's going to replace it. Still have the negative 12. And now I'm going to solve the problem. So 3x minus 6 equals negative 12. Add 6. X equals negative 6. Divided by 3. X equals negative 2. So the final answer is negative 2. Wow. Let's move on to number 2. Now number 2, you'll notice that they look very similar to each other. So in this case, if I add the columns right now, nothing eliminates because 9x plus 9x is 18x, and y plus y is 2y, and negative 6 plus negative 8 is negative 14. But what I can do is I could multiply everything by negative 1 in either equation. So I'm going to multiply the bottom by a negative 1. That's going to change all those signs. And by doing that, now when I add the columns, 9x plus negative 9x cancels out. Y plus negative y cancels out. I get 0 equals negative 6 plus 8 is 2. 0 equals 2. Now that's a special case. Does 0 equal 2 make any sense? No, it does not. So this is a no solution case. If you were to graph these lines are parallel. Let's move on to number 3. In number 3, you'll notice that the x's and the y's are not even close to being the opposite values. So when this happens, you want to multiply one equation by a number that will basically make that scenario in number 1 happen, where the x's or the y's end up being the opposites. So I'm going to take the first equation because I noticed that the 3x, if I multiply the 3x by negative 4, 12 is a factor. So I'm going to multiply the entire equation by negative 4. So again, I pick that because 3 goes into 12. So what happens is I have negative 12x. I have to distribute minus 40y equals 8. I rewrite the same equation in the second scenario below it, 12x plus 40y equals negative 8. And again, look what happens here. When I add, I'm going to get 0 equals 0. Now you might be thinking, what just happened there? Everything canceled out. That can't be the same as no solution. What must happen? This is a true statement. 0 does equal 0. So this must be the infinitely many case, because what's happening, the reason it canceled out, it's the same line. All right, let's go on to number 4. Now, number 4 is the most difficult case, because when you look at it, 10 and negative 4, they're not multiples of each other. Negative 2 and 3, they're not multiples of each other. So what you have to do is you have to find the least common multiple. So when I look at this, I see that the y values could go into a certain number. I also see that the x values go into a certain number. Now it's up to you in terms of what number you see, but I'm going to go ahead and use the y variables here for something different. There's lots of possibilities. I notice that these two both go into 6. Okay, so 2 and 3 both go into 6. So that's where I'm going to start. Keep that in mind. I'm going to multiply the top equation by positive 3. I'll explain why I chose positive 3 in a minute. So I'm going to distribute, and I'm going to get 30x. Sorry about this. The stylus is hard to write with. 30x minus 6y equals negative 48. And at the bottom, I'm going to multiply by positive 2. Now the reason I chose positive 3 and positive 2 is because I want my variables, remember, to be opposites. In the top equation, I had negative there. And in the bottom equation, I had positive. So I wanted these signs to stay the way they were. That's why I did that. All right, so when we multiply by 2, we get negative 8x plus 6y equals 26. Now, when I add the equations in the columns, I'm going to get 22x equals negative 22. So now I divide by 22. X equals negative 1. Now find y, again, I'm going to substitute into either of the original equations. I think it's going to be easiest to take the bottom equation, because the factors are small, so we have negative 4x, but I'm going to take out the x. The x is what's negative 1, so I'm going to replace that with negative 1. Rewrite the plus 3y equals 13. And then I'm going to solve. So 4 plus 3y equals 13. Subtract 4. And I get 3y equals 9. Divide by 3. And we get y equals 3. So the final answer is negative 1, 3. All right. Good luck on your homework.